In this module, we are going to see the array operations and functions from the lens of broadcasting and vectorization, and even many more. What is broadcasting? Broadcasting involves operations between arrays of different shapes. As we would see here, for example, the array 1 here is one-dimensional of 5 elements, so they are not of the same size, neither of the same shape. However, we are adding a scalar value to each element of that array. And as we see here, the result here shows that we have added 1 to each element of this array. This is what broadcasting is all about, when the shape of the operation is not the same. Vectorization, on the other hand, it doesn't matter what the shape is, it is basically the application of operations to the entire array or array-like structures in a single efficient operation without the need for explicit loops. So it means that we can decide to go through each element and say we want to add a particular number to it. However, we are not going through any kind of loop, and the shapes in this case are the same. So for example, we want to go through each element of the R1 array and we want to find the square roots. In this case, we do not need to write an explicit loop that goes through each of the elements and then we square the result. In this case, we use the np.sqrt function and we pass in the array, and that basically does the magic. This shows us how we can do the same for exponential. We also have what we call the element-wise addition, where we are adding 2 arrays, and we use the np.add function for that. For the subtract function, we are subtracting each element of 2 from each element of array 1. That is, for example, 1 minus 5, 2 minus 4. If we flip the order, it's also going to be the other way around. So if R2 is here and R1 is here, then it will be R1 being subtracted from R2. Multiplication is np.multiply by the number, the arrays. I should also highlight here that you do not have to, for some of these operations, they can be more than 2 arrays. For example, for the multiply, they can be more than 2 arrays. For the subtract, is also going to be the same. It can be more than 2 arrays, except that the arrangement is going to be in the order of how you have placed it in the arguments. Divide as well is np.divide, and it's basically have this as the numerator and this as the denominator. We can also perform certain operations like np.sum, where we add all the elements in an array. We can also do the dot product of 2 arrays. The dot product is basically, let me show you what that looks like. So let's run this so that I can use that to explain the dot product. So the dot product of an array is basically multiplying each element of the array in the same index position and summing it up. So let's look at this example. So the dot product is 1 times 5 plus 2 times 4 plus 3 times 3 up until we add it, the multiplication of each number, and that is what np.dot means, which is what we have here. We can also do comparison with array, where we are comparing each element of the array to the other element using the same index position. If they are not of the same shape, there will be a problem. This is why we say vectorization is different from broadcasting, because in broadcasting, the operations that we perform there do not care about the shapes of the array, like we see when we are adding a scalar value to a array of 5 numbers. But in vectorization, the shapes of the array have to be the same. And we see here that it returns a Boolean value in cases where the element in array 1 is greater than the element in array 2. We've seen some aggregate functions like the sum or dots, but we also have the np.min which calculates the average of the elements in the array. We can use the np.max to return the maximum value of an array. Also note that this means that we have assumed that the array have data types integers or floats. We can also return the np.min, which is the minimum value of an array. For advanced methods, we can actually append elements to an array. We have two methods for this depending on what we are trying to achieve. So this shows an array that I've created, and we can see it here before appending. When we are using the append function, it takes two arguments. The first is the array that we want to add the elements to, and the second is the list of values that we want to add. If we have just one element to add, we do not have to put it in a list. But once it's more than one element, then we need to add it to a list. And as we see here, it has appended it to the last positions of the array. The np.insert is slightly different, but they achieve almost the same goal. For the np insert, we can specify the index, that is the position that we want to add the elements of the array. That is the new element that we want to add into the array. It takes three arguments. One is the array. Two is the position that we want to insert these values. And as seen here, it has actually inserted it to the beginning because we have asked it to put it in the position. And you would see that because we have two elements here, it just assigns 7.6 to the first element and 5.4 to the second element in that order. So this is the difference between append. Append just adds it to the back of the array, while insert allows you to specify the position. We can also perform the delete function, that is deleting by the index. The delete function takes in the array and the position of the value that we want to delete. So in this case, where we have these values, we start from 0, 1, 2. And that is why we can see that we no longer have a 0.11 after deleting.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
Now we'll go into how we append to multidimensional array. What we've seen previously is adding to a 1D array. I've created a 2D array here, and it's a 2 by 3 array. That is 2 rows by 3 columns. And there are different ways we can add or append to multidimensional array. We can append by the row, or we append by the column. When we want to append by the row, the append function will take in the array that we want to append to, and then the row that we want to append, and then we have to specify the axis to be 0. If we do not specify the axis, the default axis is axis 0. But I have shown you how you can actually add the axis to this if we want to explicitly specify. If we want to append as a new column, it's almost the same, except that the axis is then going to be 1. And the way we will insert the values, because we are now inserting as a column, will be different. Because this will be the first value, like the header of the column, and then this will be the rows of that column. Let's see what that looks like. So this is before we appended, and we appended a new row. So we have 7, 8, 9 at the bottom here. And after that, we appended a new column where we have 10 as the header, for instance, and then we have 11 and 12 as the rows of that particular column. Now, I want you to do this exercise. Insert row and columns at a specific position for a 1D array and 2D array, and do the same for deleting. Now, let's move to sorting. Sorting means that we want to arrange our array in a particular order. The default value for sorting is axis 1, which I'm going to explain. Here we have actually sorted, and we use the np.sort function. We pass in the array that we want to sort, and by default, without putting any of the axes, the array is going to be sorted by the rows. So this will become 1, 4, 7. This will become 5, 6, 8. And of course, this will remain the same. So when we do not pass an axis into the function, it's just sort it by row and take the axis as 1. The second part, where we set the axis equals to none, just means that we want to flatten the array. What that means is that this will become a one-dimensional array that is actually now in ascending order. Where we want to sort by column is going to be the same function. We pass in the array we want to sort, and we specify the axis to be 0. Let's look at what the result looks like. As mentioned, these are sorted it by rows 1, 4, 7, 5, 6, 8, and 1, 2, 3. And this has flattened because we said the axis should be none. That is, we do not want any axis any longer. So that means just collapse this into a one-dimensional, and it has arranged it in ascending order. And by column, it means that we go from top to bottom. So if we're arranging by column, it will become 1, 8, 7, 1, 2, 6, and 3, 4, 5, which is what we have here. There are 2 ways that we can flatten our array. One way, or let me say 3 ways. One way that we have seen here is to sort, and then we set the axis to none. But it's 2 simpler ways is these 2 functions. We can use the dot flatten, which we use as a function on top of this array that we have created, or we use the dot ravel method. There is actually no advantage to both. We can use either of it to flatten an array 2-dimensional. And as you can see here, it doesn't arrange it in any order because we are not using the dot sort function. Now concatenating array. We can concatenate 2 arrays by using the H stack or V stack depending on the direction. If we want to stack them by the horizontal direction, we use the H stack method. So we use the np.hstack, and then we add inside the arguments a tuple of the 2 arrays that we want to add. The function for the vertical stack is .vstack. So the difference is just the H for horizontal stack and the V is for vertical stack. And as we see here, the horizontal stack has actually put them in the direction of the horizontal direction, and we can see that it has done it in an horizontal way. And for the vertical, it put it from top to bottom, which is what we see here. Now we are going to see how we can replace non-values in arrays. So I've created a 3x3 dimensional array, and I've set some of the values to be null. So we represent null with np.nan using NumPy, and we are going to define a replacement value. So it means that whenever we see the np.nan, we want to replace it with a certain value, in this case 0. And we are going to use broadcasting to do that, because we know that we are replacing with a scalar value, but what we have here is another shape, which is 3x3. And how we do that is that we pass in the np.isNan function into this square bracket of the data itself, which is the array, and we pass in the array itself and assign that to the replacement value. Once we do that, we can print the new value of our array, and as we see here, this is now 0. This is how we replace non-values in arrays. We can also perform matrix multiplication. However, I'm going to leave this to you and allow you to do multiplication. That is the dot product of 2 matrices. An int is that you use the np.dot. And I wish you all the best with this. The result should look like this, and I hope to see that you get to the end of this. In the next module, we will look at how we use NumPy with images.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.